Alright, so we're going to talk about dilations and similarity. So dilations and similarity. Now, you probably can tell that we're already in the coordinate plane and I've already got two triangles drawn. So if you want to put this on a piece of graph paper or draw your own graph nice and neat and plot these points exactly like they are, you're definitely going to need this. We're going to add a lot to this picture here in a minute. But a dilation is a transformation that changes the size of something. So, and hopefully you know that, dilation means enlarge or reduce. Okay, so in our situation here, we're going to say that the red triangle is our pre-image. So that's the first one. And the black triangle is our image. So that's the second one. The black one is the enlargement of the red one. And these two triangles are similar. I can put them together where you can see that each angle is the same. So we're not going to worry about proving that they're similar. They're similar. And what I want you to do is write down all the points. So this point right here is 1, 2. This is 5, 1. This is 1, 2, 3, 1, 2, 3, 3, 3. And then we write down the points of the black triangle, 2, 4. This one is 6, 6. And this one is 10, 2. So I want you to just take a minute and look at the points, look at the triangles, and see if you can determine how did we go from the red triangle to the black triangle. Okay, hopefully what you're seeing is that this point, 1, 2, times 2 would make 2, 4. So what we did is 2 times 1, 2 turned into 2, 4. And then we did the next point, 3, 3. So 2 times 3, 3 turned into 6, 6. And 2 times 5, 1 turned into 10, 2. So the point here is this number 2. That number 2 is called a scale factor. Okay, the scale factor is how much this figure was enlarged by or how much it was reduced by. And in our case here, we're doing an enlargement. Okay, so 2 is our scale factor. A more generic way to write that, instead of 2, we can say that the scale factor is the letter K. And the way we write that is that K times a point AB turns into a new point, KA, KB. Okay, so K was 2, 2 times 5 is 10. So this is 2 times 5. This is 2 times 1. And that's what a scale factor is. Scale factor is what do we multiply this one by to get this one. Now, that is about as interesting as it's going to get unless we start moving this picture around. So what I'm going to do is get rid of most of this writing. You still have your picture, so you can look at all that. And I'm going to make some changes to this picture here. So if I start moving these points around, say I move this point to here, and I move this point to here. Okay, now I have this nice, almost looks like a right triangle, and I have this point. Now you're not going to be able to keep up with this writing, so just pay attention to it. I have this point, -1, 3. All right, what is this point right here? Well, it's -2, 6. So did my scale factor hold? Do I still have the same scale factor? hopefully you see negative 1 times 2 is negative 2, and 3 times 2 is 6. So that's true for all these points. So scale factor is going to stay no matter what I do. So I can move this thing all over the place, and I'm going to keep that same scale factor, right? So I put it right there. Right? This point is negative 5, 3. I should expect that this one is negative 10, negative 6. I'm sorry, this was negative 5, negative 3. So double that is negative 10, negative 6. And that's how a scale factor works. Now, what makes this kind of easy is something that you may not see, and it's that all of these points this point and this point are connected to this point. And by connected, I mean I can draw a line that goes between all three of them. I could draw a line that goes from here to here to here, and I could draw one from here to here to here. And I'm going to do that, so I'm going to put these lines on there. Now, this point right here, right now you may think, well, that's the origin and that's just where it stays, but this is actually called the center of dilation. And what that means is that's the point that our dilation is based off of. So from this point 0, 0 to get to this point, I go over 1, up 3, and I get to this point 1, 3. Well, double that is over 2, up 6, and I get to this point 2, 6. And that's all well and good as long as everything stays around the origin there. But what can happen is we can move away from the origin. So I can take my center of dilation and move it to here, move it wherever I want. Now I look at how far am I from this point. So I go over 2, up 4. Well, I should expect the next one is double, so I'm going to go seven, 8. Okay, so as I move my center of dilation around, does it change my scale factor? If you look at this point was 1, 3. And now it's turned into negative 4, 0. Well, that doesn't look like much of a connection, but you'll see that from here, so down 3, over 5, and then if I want to go to the new version of that point, I go down twice as much, and I go over twice as much. So this is down 3 over 5, this is down 6 over 10. So my scale factor has stayed the same thing is happening, but it's not that I'm just multiplying the points by 2. I'm actually multiplying this distance by 2. So I could do some Pythagorean theorem stuff here and figure out the hypotenuse of this right triangle and then double it, and it would equal the hypotenuse of this entire right triangle. So that may not make any sense, maybe a little more than you wanted to know about dilations. What we're going to do is we're going to work from the origin. Most of the things you do are going to look like this. There's not going to be any lines on it, and you're basically just going to have to say, how did I go from 1, 3 to the point 2, 6? Well, 1, 3 times 2 equals 2, 6. So my scale factor equals 2. Okay? So anyways, that's dilations. We're going to do some more with similarity in class tomorrow, so if you have any questions, make sure to bring them in.